We want to implement Quicksort. So what is Quicksort? It's a sorting algorithm that will sort an array of integers, of unsorted array. And how it kind of works is you just want to, it's like divide and conquer kind of ask. So what you do is you pick an index and you compare it, and you would create two subarrays. So like in this instance, we want to use just switch colors here. I'll just stick with black. We want to choose 4 as our pivot. This will be our pivot. And then what's called the pivot. And what you do is you iterate through all of the elements or the inputs in the array to 4. And if it's less than 4, and then so is 7. Is 4 greater than 7? Yes, we let it be. And then is 4 less than 2? So it is. So what you would do is you swap 7 and 2. So then you would have 2, 7, 1, 6, 8, 5, 3, 4. And then you do that through all of the elements. And then we have this thing called the pointer array. So we always set it at 0. So since it was at 0, this is a 0 element. Let me switch it back to something else here. I'll do red. And then once you do a comparison, you always want to, once you do, like, so we did find one, which was 2, then you always want to increment the position point index to 1 more. So this now would be 1. So we just did our swapping of 2 and 7. But now since the pointer is at 1, we start at 1. Anything right than 1. So is 4 greater than is 1 less than 4? Yes, it is. So then we would do another swap here. So it would be 2, 1, 7, 6, 8, 5, 3, 4. And then since we did a swap, we want to increment this by 1. So now the position would be 2. So now we start at the second one. The right of the second one would be 7. So is 4 greater than 6? No. Is 4 greater than 8? No. How about 5? No. Is 3 less than 4? Then yes. So then you switch 3 and 7. So then it'll be 2, 1, 3, 6, 8, 5, and this would be 7. And then since you iterated all the one, then you would iterate, since we iterated all of them, we would return the 2 subarrays, and then we curse it, and we would call Quicksort. Since right here is the pointer, you would call Quicksort in this subarray and Quicksort in this subarray. And recursively, if you keep doing that, it will sort all of the elements. And yeah, you're pretty much done. So that's how that kind of works. And then on the concept level, so how to implement that in code. You see, yeah. So these are just a helper function called swap that just swaps 2 elements in an array. And then here's another element you need, is the partition element. So that's the meat that does all of the algorithm that implements the pointer index and the swapping. So partition, yeah, so this one, what it does, it just does the work of looping and iterating and swapping on splitting of the 2 subarrays of the partition, and then when it's all done, it will return the partition index of the array. So you can see here, yeah, your pivot's going to be always your, it takes your array in the left and right. These are just indexes, so your right array would be the very last index. And then your partition is always on the, you always start on the left, the 0th, so this would be 0 on this. If it was like a length of 10, this would be 9. So you just iterate it, and if your current element you're looking at is less than the pivot, then you want to do the swapping and then the incrementing of the partition index. And then when you're all done, you want to always swap your pivot, because it's a small one, to the right side of your small subarray, and you just return the partition index. So and then so here's the quicksort function. Let's just call it QS. It takes an array that you want to organize, and then the left and right. I should probably have put index in here just to say these are zeros, so these are both ends. And then so then you just instantiate your, a pivot variable and a partition index. And since it's recursion, since it's QS here, we're calling it here. Our exiting logic, or a base case, is while this is once the right side, your right is less than the left, that's your exiting. So that's when you would exit. All the while, but nonetheless, when left is greater than less than right, you want to set your pivot to the last element, which is your right, in the subarray or the array, and your partition index, which is be your new what it returns from your partition function here. Then while that's true, you just always call a quicksort on the unordered subarrays to the left. This one will do your smaller subarray, and this one you do your right subarray. And when you're all done, your array should be ordered, and then you just return it. So if you look here, X is just an unordered array of ints, and then if we call quicksort on that array, it should cancel out all these in order. And which it does, 2, 3, 7, 9, 34, 34, 84. So, but yeah, apparently this is very efficient. And worst case scenario, it's just log n squared, or big O of n squared. I mean, what am I doing? That's worst case, but never you usually get that. But usually apparently it's log or big O of n log n, which is pretty decent. So hence quick sort and quick.